Okay, we're going to do a question 2, and this question is to do with relative frequency. Now, relative frequency is just experimental probability. So it's just the probability that you get once you've done an experiment. Now, in this question, a dice has been thrown 20 times. And what's happened is the number that was got has just been written down. So there are 20 numbers because they've thrown the dice 20 times. Now what I'm going to do is just tally the numbers that have been got. So if I count the number of ones, I've got 3 ones. The dice was thrown 20 times, so the relative frequency, which is just the probability, is 3 out of 20. If I now tally the 2s, I've got 3 2s. There they are, just cross them off. So that would be a probability of 3 out of 20. If I now tally the 3s, you will notice that I've got more 3s. I've got 5 altogether. So the probability, the experimental probability of throwing a 3 is 5 out of 20. And don't forget, the experimental probability is called the relative frequency. So if I now tally the number of 4s, I've got 3 4s, so the relative frequency is 3 out of 20. The number of 5s, again, I've got 3 5s, so the relative frequency, the experimental probability of a 5 is 3 out of 20. And last but not least, I've got 3 6s. So the experimental probability, the relative frequency of a 6 is 3 out of 20. It's worth in an examination at this point just counting to make sure that you've got 20 altogether. 3, 6, 9, 12, 15, 20. So you've probably not gone wrong. So that's worth 2 marks. We're now going to do the second part of the question. And this is the second part of the question. And the second part of the question says, use the relative frequency to calculate how many times you would expect to score a 3 if you threw the dice not 20 times, but 60 times. Now the relative frequency of a 3, if you can remember, we had more 3s than anybody else, or any other number, was 5 out of 20. So what we do is we imagine that that is the probability of getting a 3. And this time, we're throwing the dice 60 times, so the sum we would do would be 5/20 of 60. Now if I just cancel that down, that gives me 5 times 3, so I would expect to throw 15 3s if I were to throw this dice 60 times. Now part C says compare your answer to B with the number of times you would expect to score 3 in a fair dice. So to do this, you need to know the actual probability, the theoretical probability of throwing a 3 in a fair dice. Now in a fair dice, there are 6 numbers, 1, 2, 3, 4, 5, 6, and only one of them is a 3. So the probability of throwing a 3 is 1 out of 6. I'm going to throw this dice 60 times, so I would expect that number of 3s if I were to throw that dice 60 times. 6 goes into 60 10 times, so I would expect to throw 10 6s in a fair dice. So it looks as though this dice here is biased.